Hey guys, welcome to this snowy morning in Habersham. We are going to solve exponential functions in this lesson. Not really complicated ones. Most of those are going to be saved for higher up in high school. But for right now, we're just going to do really simple ones. I'm talking about when x is up in the exponent. So let's go ahead and get to it. In this last lesson of Unit 4, we're finally going to show you how to solve exponential equations. So our learning target for this lesson is I can solve simple exponential functions. This is going to be situations where your variable, the thing that you don't know, is in your exponent and you've got to isolate that x. So all of the tricks we've learned up to this point for solving equations won't work here. Most exponential functions can't be solved within this course. We're only going to be looking at the simplest ones that basically you're just going to have to use your number sense to solve. And here's what I mean by that. When you look at an example like this where we have 5 raised to some number equals 125. In this course, we're not going to give you an actual method of solving that. Instead, you have to think, okay, how many times would I have to multiply 5 by itself in order to get to 125? If nothing comes to mind immediately, you can just sort of start working it out and guessing and checking. We know 5 to the first power is 5. 5 to the second power would be 25, so we know it's not 2. 5 to the third power would be 5 times 5 times 5, which is 125, which means the answer is 3. 5 to the third power is 125, so x equals 3. Like I said, these are going to be very simple, so the answer is never going to be more than 1, 2, 3, 4. We're going to be giving you really easy ones to figure out. There are official methods for solving it, just not in this class. So if you've got one like this, in order to be able to use this trick, the easiest thing to do is going to be to isolate this little exponent here. So we have 18 equals 2 times 9 to the x. What I'm going to do first is get rid of that 2. So I'm going to divide by 2 on both sides. That cancels it out here and leaves me with 9 equals 9 to the x. So now I've got to think, how many times do I multiply 9 to get 9? That would be 9 to the first power is equal to 9. So x equals 1. And that's all we're doing. If it's an inequality, it's going to work exactly the same. Think back to when we were talking about linear equations and quadratic equations. Inequalities are exactly the same like equations. Not exactly the same like, exactly the same as equations. So here I'm going to start by dividing off this extra 2 here, which leaves me 2 to the x is less than 16 divided by 2 is 8. And then I'm going to work through this same process. 2 to the first power won't work, that's just 2. 2 to the second power is going to be 2 times 2, which is 4. 2 to the third power gets me 8, which means x is going to be less than 3. Again, the only difference between the inequality and the equation is that you're replacing that equal sign with the less than sign. Right, there is actually one application to this that will work in this course, and that is when we ask you to find the x-intercept. So I'm gonna show you how that would work. If you want to find the x-intercept and you don't have the graph in front of you, we know that the x-intercept is the point where the function crosses the x-axis. So if we could graph it and we could look at it, it would be the point where that function is crossing over the x-axis. Because it's crossing the x-axis, we know that the y value is 0. So if all I have is the equation and there's no graph paper in sight, all I've got to do to find that x-intercept algebraically is plug 0 in for my y, because I know that the x-intercept is going to happen when y is 0. So right here, instead of writing y, I'm going to write 0 equals 3 to the x minus 9. And then I've got to try and get this 3 to the x. Basically, I'm trying to isolate that variable. I can't quite get it isolated, but I'm going to get it as close as I can. So I'm going to add this 9 to both sides of my equation, which gives me 9 equals 3 to the x. And then I think, what do I raise 3 to get 9? Hopefully, you all know that that's going to be 2. 3 squared is equal to 9. So that means that x is equal to 2, which means the x-intercept of this function is the point 2, 0. So the ordered pair 2, 0 would be your answer. So that's sort of an application type problem. We just embedded those application problems right into the practice, which means you have no application for this lesson. You just have practice problems. So go ahead and try those. Let us know if you need any help, and then get ready for your mastery check.